Hello everyone. Welcome to the video lecture series on Simplex method. I am Professor Mayur Gohil. In this video lecture, I am going to solve a question based upon Simplex method. This is what we were eagerly waiting for, how to handle LPP using Simplex method. So let us take up the following question. Let's write down the first thing. Here the question is, solve the LPP using Simplex method. Now let me give you the question max z, okay, which is 2x1 plus 5x2 subject to the condition constraints x1 plus 4x2 is less equal 24, 3x1 plus x2 is less equal 21, x1 plus x2 is less equal 9, x1 x2 greater equal 0. Now this is the LPP. Now before I go on to solving the question with Simplex method, I request you to subscribe my channel if you are first timer on this channel, and I request you to hit the bell icon for all the notifications for the further videos that I would be making. I also request you to hit like button because it does motivate me for making more videos, and you know obviously it does help me in making a better video and making the whole experience a good learning. So please do consider subscribing and hitting like button, and please do hit bell icon also. So now uh, let me move on to solve the question. Now see, Simplex method, in order to solve the question, there are lot many steps and lot many explanation at every single step that we are going to do. So what I will suggest you to hold patience, because this is the first question that you are doing with me, and hold on with every step. Don't rush to solve the question just by seeing the steps, but once you develop your command over the method, I allow you to rush towards the solving of the problem, because it's a laborious task to solve it, because it's a long method and you have to consecutively solve from one table to another table. Another very important thing is there. One word of caution I would like to give you, that in examination, if you are attempting this method, you can keep it at the end of your exam, okay? Or I mean to say, you solve your entire question paper first, and if there are many questions, then there is no option, but if there are one or two questions, then you can solve afterwards. Keep these questions at the end to solve, because they would be time consuming. That is one thing. Another important thing in this method is there, like when you get your answer book to solve these questions, I would suggest you to take 2 pages together. I mean to say, that is, you, if this is your answer paper, so you must, this is your answer paper 1, answer page 1, and this is your answer page 2. Okay, keep your answer page in this way, so that here you solve your Simplex method. You start here, okay, this will be your starting place, and then you can carry you're working on page 2 also, so that what will happen, we can avoid turning of pages. So one side by side when you keep, you will be able to do your work better, without the chances of your error will minimize. Okay, so no mistakes would happen, or we will try to make less and less mistakes when we don't turn the pages. Okay, so this is one very important thing, that whenever simplex method is there in examination, try to write like this way. Okay, this kind of pages you should take up. Now let me start with the main portion of your simplex method solving of the question. So step number 1, here I'll write down here. Step number 1, given LPP, is to be converted, to the standard, to its converted to its standard form. Okay, this is the first step in LPP, converted to its standard form. This is the first important step. So I'll write here, this is step number 1. So converting it to the standard form, we'll write here maximization max z, that is 2x1 plus 5x2. I'll keep some space for some more variables entering, subject to the constraint, that is the first constraint that was given to us was x1 plus 4x2 is less equal 24. So I'll add the slack variable over here, here I'll add s1, which is equals to 24. Okay, here then I'll add 3x1 plus x2 plus s2 as the slack variable, and that is 21. And then here you have x1 plus x2 plus s3. Here the third variable, slack variable, we have added, and we make the equation as inequality as an equality, that is equal to 9. And finally we write down the non-negativity condition, which is x1 x2 x3 s1 sorry, not x3 but x1 x2 s1 s2 s3 greater equal 0. So here it is 0 s1, we add them to the objective function, 0 s1, 0 s2 and 0 s3. Even if you write or you don't write, it's not a big issue, but now since we are converting it to standard form, you better write, because we will need them. Now we go for formulation of the table. Now different authors have different tables made, and we will make a standard table which helps us to get everything into our table. Okay, that will, so that no ambiguity remains. So let us make the table now. See how the table is made, and be very careful while making the table, because these tables we have to carry forward also. So what I would suggest, you take a fresh page. Okay, I'll write down here. Step 2 is making table. Okay, step 2 is making table of simplex method. So suggestion is that, suggestion from my side is, take fresh page. Okay, take fresh page, because fresh page, as we will need to extend the table below. Okay, we will need to lengthen the table, so we won't extend the columns, but table will be extended. So you start from a fresh page. This is one very very important thing. Now let us see how to handle this here. So what all things are required, we will get everything from our uh, the format of the standard form that we have written. We will get all the things from there. So I'll write here this is a simplex table. Okay, so I'll put the heading here as with the green. I'll put here this is simplex table. Now this is an iterative method, so why do we need to extend the table below? Because we need 2 or 3 or more iterations will be there. Okay, so because 2 or more or 3 iterations, so that many tables we will need. So simplex table now we are making. Okay, so what all things are required, let us see first we will need one column of one we will I'll show you what all things are required, so accordingly you make the table. So first is the thing that we will need is, I'll write here, we will need cj meaning the coefficients of the objective function. In the objective function, whatever number of variables are there, we would need that many coefficients. So here and below cj we have something called as basic variable. If you write basic variable, or you can even write basic variable, or I will be writing here basis. This is the main word here, basis. This is the word. So what is the thing now? So basic variable meaning, I'll just put here, that is we will need basic variables. The standard name is basis. We will need this. So first we write down the basic variables which are there. So what are all basic variables that we have here? The first is x1. Now I'll write here x1, then there is x2. Okay, then there is s1. We have inserted the variable s1, then there is s2, and then there is s3. Then above x1 we write the coefficient of x1. So coefficient of x1 in the objective function. Okay, here we write 2, which is 2. Then here it is 5, here it is 0, here it is 0, and here it is 0. So these are the coefficients that we wrote. Now comes the next thing. After S3 we will need something called as the RHS. The RHS in the what we call the constraints which was there, we would need that. So that one column here we will make, that is RHS. Okay, that is what we need now. Now here the number of the slack variables that we have got, we would need them, and ahead of basic variables, we would need here one name of the column is there, CB. I'll tell you what is CB. That one column that is also required. Now let us see how to write down. So first, this is the format I am giving you, and then later on we will start writing down all the details. So S1, here there is S1, here there is S2, and here there is S3. So S1, S2, S3 we write down. Then now corresponding to each x1 and x2, we write down all the values of the constraints that we got. So whatever coefficients of x1 were there in the constraint, that we have to write. So in the first constraint, x1 had coefficient 1 over here, x2 had coefficient 4, right? Yeah, and the coefficient of s1 was 1. Coefficient of s2 in the first constraint is 0. Here it is 0 for s3 also, and the RHS is 24, so we write down 24 over here. Okay, same way for the second constraint. For the second constraint we had 3 over here, then we had 1, s2 value is 1, all others are 0. Constraint was 21. Okay, maximum is 21, equal to we did right on RHS, we have 21. Okay, now S3 when we are writing in the third row, for S3, in the third condition, the constraint we have 1 and 1. Now S1, S2, S3 when we write, so S1 will be 0, S2 will be 0, S3 will be 1, and the third constraint had RHS equal to 9. Okay, so we got our basic things filled up. Now how did we fill up? Let me help you out once more. And the here, what is CB? Let me help you out with what is CB. CB is nothing but the coefficients of current basic variables in the objective function. Basically, they are current basic variables are s1, s2, s3, so their coefficients is 0, 0 and 0. Okay, so these all things we write down here. So let me explain you what all things we wrote, and now I'll give you the explanation over here. So first thing, cj row of cj. Okay, row cj is nothing but the coefficient of variables in objective function. Objective function z. Okay, that is the meaning over there. After that, what is cb? CB is nothing but, I'll write here CB because I need one more column I need. So CB is the coefficient of, it's a CB column, column CB. Column CB is the coefficient of current basic variable. Current basic variable in the objective function. Okay, now we got all these things. This is the first table, so this is called the first table of a simplex method from which we started. Okay, so this is table number 1. I'll label it here. This is table 1, or I'll just write here, this is table 1. Okay, now there we need one column to start to go to table number 2. So how do we go to table number 2? Let me help you out. This is basic thing that we needed, and we have got that. But now in order to go to table number 2, there is one column and two extra rows are required. Let me help you here. What is that? So firstly, we will need here one row called as zj. So the row zj is this. Now how do we calculate this row? This row is zj is calculated by the following formula. Zj is equals to summation cb into aij. Aij meaning we will be having here all these elements are taken into consideration. So these elements multiplied with this, so this one vector multiplied with each column, we will get some answer. So what it is, let's see. I'll help you out with what it is. So let me help you out with how to calculate this. So here this is zj is first this vector value 0 into 1 plus 0 into 3 plus 0 into 1. So in the first table zj is always 0. There is nothing going to work in that. So all these values are going to come to 0 and 0 only. No problem here. Okay, zj value is 0. I'll give you the explanation here that zj, I'll tell you how did you get over here for each value. Okay, so here you get this. Now one more row is required, which is called cj minus zj. Now this cj minus zj is calculation of the topmost row minus the zj row that we got. So how do we get the value here? Here this is 2 minus 0, which is going to be 2. 5 minus 0, which is going to be 5. 0 minus 0 here is 0, and 0 minus 0 is 0 again, and 0 minus 0 is 0. All three zeros, right? In the new in the uppermost row we have all zeros, so they are all going to be 0. So when you calculate here, this value is going to be 2, here it is going to be 5, here it is going to be 0, here it is 0 and 0. Now comes the next part, the very important part, which will help us to decide which is the key column. So because the problem is of maximization type, okay, because the problem is of maximization type, we will take that column to be the key column whose cj minus zj is maximum positive, okay, which is positive and which is maximum. So here we will take the largest value of the column of cj minus zj, which is maximum and positive. So here I see that this is the value which is maximum and which is positive. So this column is our key column. Okay, we can label this here, which is a key column. So I'll call this as key column. Now what will happen next? In order to find the key element, we need something called as a ratio. So that ratio we calculate here. So how do we calculate? We divide the elements in the key column. Okay, here we take the key column and the elements of the RHS are divided by the elements of the key column. So what do we do? Here the ratio is obtained in this way. It is basically 24 divided by 4. We get 6. Then 21 divided by 1 we get 21. 9 divided by 1 we get 1. Alright, sorry, 9 divided by 1 we get 9. So here this ratio here which we got, this ratio is called replacement ratio. Okay, and out of this ratio, whichever is minimum, we choose that. So we always choose the one which is minimum. So here it is, this element is minimum, 6 is minimum, therefore this is called the key column. Okay, a key row. Now I write this CB over here, CB coefficients, but now this is all about key column, key row and key column. So this is key row. So this is called the key row. Basically this full row is called key row. Okay, and this element that you see here, this element is called the key element. Key element. It is very important to note all these small definition, and it takes time to digest. So slowly and gently proceed. Now, having decided what is key row, what is key column, we proceed further. Okay, yeah. So I'll just, and in exam you need not write all these things. Okay, you just have to mark them. In exam you just mark which is key row, which is key column, and mark the key element. You need not write around it, this is key row, this is key column. No, nothing. You just mark the arrow. By arrow it is understood that this is key row, this is key column. Fine. And after that, here you, I'll just keep it here for you people. This is key column, this is key row. Okay, now we do another thing. This helps us to go to table number 2. So we go to table number 2 now. So while going to table number 2, we will not write all the columns again and everything. We will just keep our table as simple as possible without any ambiguity. We will just put a line here. Okay, we put a line and we continue the headings the way they are. Okay, but here once you obtain the key row and the key column, there is one very important thing to be noted and to be written down before writing table 2. So here we write down that x2 is going to be the entering variable and s1 is going to be the leaving variable or exiting variable or outgoing variable. So here we write down x2 x2 is entering and s1 is leaving or leaving variable. x2 is entering and s1 is leaving. We write down this, okay, and then we make the table 2. So what happens now? See, I'll again put a line here. Okay, now see how to handle this. So the column remain the way they are, no change in the column. We are just going to write everything one below other. Okay, the main heading you take it down all throughout. So what will happen now, at where the basic variable that we wrote, I'll just write it for the reference purpose. You need not write it again. You just write at s1 place. We will write here at the place of s1 we will write x1. Okay, at the place of s1 we write x1 and s2 and the place where s2 and s3 are there, they remain same. S2 and s3, they remain one and the same, no change. Now what happens next? Here cj, which was there above it, that row is also fixed, no change in that row. 2500, they will remain the same. This cj row, if you write only once, that is also okay, no change in that row. Here we will have zj, no change in that row, but in cb column there is going to be the change. What is the coefficient of x1 in the objective function? That will come over here, so that is 5. Coefficient of s2 is 0 and coefficient of s3 is 0. zj, no change, and what we will need here is cj minus zj. So cj minus zj is required. Now starts the play. The play is like this. Okay, so for your reference I'll put the variables in the initial place for some time. x1, I'll put the variables here, that is x1, x2, here it is s1, s2 and s3. Now starts the game. The game is like this: how to calculate the new values that come into the picture. So first thing is that the row in which we said it is a key row, okay, divide that entire row by the key element. Okay, so here you will get divide, since I need everything here, I'll just write it in the corner. Divide entire key row by key element. Do that. Once you do that, what you get, write down. So we get over here 1 by 4, then I get 1, then I get 1 by 4 over here, then I get 0, here I get 0, 24 becomes 6, right? Yeah, we don't calculate the ratio now, ratio is calculated afterwards. And entire key column, okay, this is first thing you do. Second thing, entire key column you make it a unit vector. So unit vector meaning it is 100 or identity, okay, 100, that way you have to make it, how they are there. So here it is going to be 1 0 and 0, that's how you make it, 1 0 and 0. Done. Having understood this much, entire key column is to be is to be made as a unit vector, as a unit vector of form 1 0 0 0 0 1 0 0 or 0 0 1 0. So we have made this element 1 here, so all other elements are going to become 0, okay. So that's what you have to remember. Now see why I am giving you other formats, because wherever, if the second row was the key row, then we would have made 0 1 0, okay. If the third row was the key row, then we would have written 0 0 1. Alright, accordingly, whatever is the case, you write accordingly. Now how to find the other elements? There is a formula to find the other elements. Let me give you how to find here these elements, how can we do them, how to obtain all these new elements here. Like say if I want to find this element, this, all these elements, how am I going to find them? So there should be some formula to find those elements. So the formula is like this. Let me give you that formula. Please note down this formula. It's a very important and a very important and a very easy formula, but this will ease your calculation. Every author has a different way of explaining this, so I am giving you the one which is the most easiest and most fastest to calculate once you understand. Otherwise you will keep on calculating those fixed ratios and then row column transformations and all, and you will be dead by doing calculations. So just see this formula. So new element is equal to, the formula is like this: old element multiplied by key element minus the corresponding key element in key row times the corresponding element in key column divided by key element. Key element. This is the main formula. If you remember this formula nicely, then there is no harm in calculation. Now see, in order to calculate the new element, we don't need the new table. We always need the old table, the previous table. So now let me show you how the element is calculated. I'll show you. See, what does it say? The new element, I'll calculate the element over here. Okay, this is the number I am calculating. So at this place in the green box I want to write the number. How it is calculated? See, the formula is saying old element is 3. Okay, I'll just do a rough work here. Old element is 3. Okay, multiply it with the key element. So 3 into 4, 3 into 4, the key element is 4. Okay, 3 into 4 minus the corresponding element in the key row. So what is that? 1. So it is 1 multiplied by the corresponding element in the key column. So what is the corresponding element in the key column? It is again 1. It is this one which I am talking about, and this one which we just took. So 1 into 1 divide by 4. So we are going to get 12 minus 1 upon 4. So here the element we will get is 11 by 4. Okay, so see here, please be very careful how do you calculate this. This element we get is 11 by 4. Once you are able to calculate this element, you feel relieved, you know. It is an amazing feeling how out of that complication you got that element. Now let me again help you how it is done. So I'll tell you the one technique which my teachers also taught me, and this is the same formula, but this is little bit, you know, shortcut way. It's a very good way. I'll show you that same thing here. See, in order to calculate the element corresponding at this place, at this 0 here, I am now doing at this place, the one in which I have put a red circle, or this red box element I want to find. How am I going to find that element? Go to the old table and see what element is there. 0 is there, right? So 0 multiplied by 4. Do the cross multiplication. Basically make a rectangle and see here. This is the rectangle we made. So do the cross multiplication. 0 into 4 and 1 into 1. 0 into 4 minus 1 into 1 divided by 4. So that is minus 1 by 4 is the answer there. So this is what we get. I hope this is clear. I'll again explain you. See, what you need to do is make a rectangle. Make a rectangle over here. In order to have the value at this box, okay, at this box we see the corresponding element in the previous table. So the value is 0 over there. So I want what is the value of 0 in the new table. So in order to have that, you check what is the box, where is the box corresponding to the key element. Key is element is here, so make a box like this. Okay, this is the box that gets created. Now, so diagonally you multiply 0 into 4, hold the place where you want, write that element first. 0 into the key element, so key element should always be there first, minus the corresponding elements on the diagonal, 1 and 1. So 1 into 1, so they are the element of the key row and the key column. So 1 divided by the key element, so you get minus 1 by 4. Okay, I'll do this calculation each time for you people, so you know you get the confidence. And let me help you out again. See, so here I had got minus 1 by 4 as my answer. Now let me help you out with the next calculation. So the next one I am calculating it for the this box, okay, the purple box at S2 S2. How will I get? See the previous element. So the previous element is 1 now. Okay, so I will make a rectangle here. I'll make a rectangle like this. In my mind I'll make, okay? Don't draw on the table actually. I can erase here. You won't be able to erase in exam. So make a box like this. So what happens? 1 is the element here. So 1 multiplied by 4. And corresponding diagonal element 1 and 0. 1 into 0. Divided by 4. Which 1 and 0? These are, this 1 and this 0 are getting multiplied. Okay, so divide by the key element, that is 4. So I'll get over here 4 minus 0 upon 4, I'll get 1 again. Okay, not a problem. So this is how the element is calculated. So here I got answer 1. Okay, now what about the next one? The next element of this box I'll calculate. How do I get that element? Let us see. So okay, here I'll take this. At this box corresponding element is 0, so I'll make a box over here like this. So it is basically 4 into 0 minus 0 into 1, correct? So here you get this and divide it by 4. So basically answer is 0, but how you got this 0, this is very crucial. Okay, so here you get the answer 4 into 0, 0 into 1 divided by 4. So that's 0 as the answer. Now again, here below 6, how we will get? What is the answer that we will get? Let us see. This 6 is not the ratio I'm talking about. This 6 is the RHS. Okay, remember here this is RHS over here. This is not the ratio. 24 got divided by 6, that's why you got. But now corresponding to 21, what will come? We have to write. So corresponding to 21, let us see what comes. So let us see the previous part in the table. In the table, make a box like this for your understanding. Make it, no problem. So 21 into 4, so it is 21 into 4 minus 1 into 24. The diagonal elements you multiply, and 21 you should always keep the first. Whichever element you are taking, means whose position you are calculating, that element should be kept first. Okay, and remember it is always to be multiplied with the key element. So 21 into 4 minus 1 into 24 divided by 4. So how much do you get? That will be 84 minus 24 divided by 4. So here you have 84 minus 24 is 60, and divided by 4 you will get 15 over here. So I'll write 15. Okay, so this is how you get 15 over here. Now let me help you out with the next value. Same way we calculate the next value in the next row. So here it is all we have to calculate. So let us see how to calculate now. So corresponding to 1 I have to calculate the value, sorry, so I am calculating the value over here in this box. Okay, so how do I get that value? So that will be, again I will make a box here like this. So it is this box if I make. So 1 into 4 I will do. So 1 into 4 minus 1 into 1 divided by 4. So this is going to give me 3 by 4. So my answer here will be 3 by 4. The next answer. Yeah. The next answer I have to calculate is for 0. So see, now always don't be under impression that it is, since we are calculating for 0, so 0 will be the answer. No, it's not possible all the time like that. We have to go by the formula. So here is what we are calculating: 0 into 4 minus 1 by 4. So answer will be minus 1 by 4. Okay, minus 1 by 4 is the answer. Again, in the next part, when we take here, see, make this, here it is 0, not a problem. 0 into 4 is 0, minus 1 into 0, so that is also 0, no problem. Okay, so here we'll write it is 0. This value is 0. Oh yeah, and please remember, all these colors I am not taking in a specific way. I'm just keeping you people for understanding right now. Now year 1, when we are taking for 1, how will be the answer calculated? Make a box like this and see, 1 into 4 minus 1 into 0 divided by 4, so answer is 1. So I get the value 1 over here. Regarding 9, what will happen to 9? For 9, again 9 into 4 minus 24 divide 24 into 1. Okay, for 9 here it will be, all this rough work you need to do in your exam. So keep a rough page next to you, or keep a page in your answer booklet so that you can do the rough work properly. So here you get your answer as 9 into 4 minus 1 into 24, right? 1 into 24 divided by 4, so this is 36 minus 24 divided by 4, so 3 is the answer. Okay, so here you get 3. Now finally we are completed with all the values that we wanted in the main part of our table. All these values are done. Now starts the calculation of Zj. Now be very careful how to handle Zj. Zj is calculated by, it's a basically a dot product. Remember that it's just a dot product. 5 into 4, 5 into 1 by 4, so this is 5 upon 4, and then these zeros you just multiply and add, they will give you 0 only. So here this is 5, multiply 5 over here, this column is for CB column. Okay, yeah, then there is 5 by 4, here it is 0, here it is 0, all these are 0. And if you multiply with RHS also, this is going to give you 30, but if you don't calculate this right now, it is okay, no problem. If you don't calculate this, it's fine, but you can keep it at the back of your mind that this is value is 30. Now we will need to calculate Cj minus Zj. Cj minus Zj is basically the value Cj that you have calculated in the beginning, 2, right? That is Cj, and Zj. Cj minus Zj is 2 minus 5 by 4, that is going to be 3 by 4. Okay, here it is 2 minus 5 by 4. This 2 came from the table number 1. We have already written Cj up. Okay, so Cj minus Zj is this, so it is 3 by 4. Then next there is 5 minus 5, so this 5 minus 5 is 0. The next one we will get here, there is 0 minus 5 by 4, so this is 5 by 4. Here it is 0, here also it is 0. Now we need to calculate the Zj, Cj minus Zj, and we need to check that which is the maximum positive value. Maximum positive value is 5, maximum positive value, let me see, Cj minus Zj, oh wait, here it is 0, here it is going to be minus 5 by 4, because it is 0 minus 5 by 4. So yeah, S1 coefficient was 0, so it is minus, so the maximum value is going to be this here. Okay, 3 by 4 is maximum positive, and that is what we get. So this becomes the key column now. So here this becomes the key column. Here if you want to write, you can write that this is key column. Now what is the key row? In order to find key row, or rather I'll just say, just a minute, key column here, key column is this one basically. It is still here only. Key column is still here. Zj, Cj, Zj and Cj minus Zj, they are not considered into the key column part. Okay, they are calculated afterwards. The main table is this much. Till here all these main values, till S1, S2, S3, what is there, that is the main constraint, right? Because of those constraints we are taking all that into the picture. So now we have to find key row. How do we get that? We have to take the ratio. So that ratio we will calculate here. So the ratio is, how much is that ratio? Let us see. 6 divided by 1 by 4. So 6 up divided by 1 by 4, that is 24. Then here it is 15 divided by 11 by 4. How much is that? That is 60 upon 11. 60 upon 11. Then what is the next one? 3 by 4. Oh sorry, 3 divided by 3 by 4. The answer is 4. So we have to choose the value from the ratio which is minimum. Okay, which is minimum. So here 4 is minimum. 60 upon 11 is going to be something 5 point something something, so that is again a larger one. So I have got the key row, so I'll write here key row. Okay, key row. In exam you can mention what is key row, key column, and you can highlight the row and the column, no problem. But then remember whatever is a key element. Sometimes some people put star for the key element, okay? It is some star they will put, and that is also okay. Here they put some star like this. So this is the key element, that's what they try to indicate. Now here we have to say who is entering and who is exiting. Oh, we wrote here x2, okay? Here we have to write x2, not x1. x2 is the entering variable. x2 is entering and s1. So now here we will write down that element which is entering and which is exiting. So this formula which I have given, you remember this formula, because now I am going to write the third table. So this was table 2, okay? Your iteration number 2 you did right now, table 2. Now we write down all the details, who is entering and who is exiting. So I'll just put like this. Hmm. So here I'll write down that x1 is the entering variable and s3 is the exiting variable. x1 is entering and s3 is leaving variable or exiting variable. So you write down that, and then you make, if you want you can write down all those things again, but no need. But what is important is the heading that you will need now. So the headings don't change generally, you have only these things: x1, x2, s1, s2, s3. What changes in the rows you have to remember. So here you will have x1, no, that is x2 there, x2, s2, and here you have x1, and this is your CB column, okay? CB. So here you had 5 already, s2 has 0, x1 column, here you mention what has come. So x1 column 2 will come, okay? So 2 has come, and now comes the next part. Again starts the whole process of iteration. Be very careful while how to make the iteration. We have decided what is key row, what is key element and everything. So in that row, divide that entire row by the key element. So 3 by 4 divided by 3 by 4, I get 1. 0 divided by 3 by 4 is 0. Minus 1 by 4 divided by 3 by 4, okay? Minus 1 by 4, I'll just write here, minus 1 by 4 divided by 3 by 4, so it's going to be minus 1 by 3. So here it is minus 1 by 3. S2 divided 0, that's 0. 1 divided by 3 by 4, that is 4 by 3, okay? 4 by 3, yeah. And here we will need all those RHS back, or whatever we get we will see, and dividing 3 by 3 by 4, we get 4 as our answer here. So here it is 4. Alright, now the key column has to be converted to identity. So 1 I made here, and 0 and 0, that like those unit vectors that you have, 1 0 0 I j k type. Yeah, that is what you have to do over here. So I made it 1 0 0. What about the other one? Again, we will now need to calculate all these entries by the formula that you see up. So that formula is nothing but old element into key element divide minus corresponding element in key row into corresponding element in key column, whole thing divided by key element. Let us do this now. करो इसको कैसे करेंगे, let us see. So we go to the old table back. So one table back you go in the second table. In the table 2, what all things is happening, let us see. We have to calculate here only these many elements we have to calculate, right? So for 1, how we will get that? So make a box. Okay, if you are comfortable with that making box. So see here, I'll make a box here like this. 3 by 4 into 1 into 0. So I'll get 3 by 4 divided by 3 by 4, I'll get 1. I got 1 here answer. So this is 1. Next, here 0 into 0, all that is 0. No problem. Next, 1 by 4 into 3 by 4, 3 by 16, and minus of minus is plus 1 by 16. So 9 by 16 is what I get, divided by 3 by 4. So 9 by 16 divided by 3 by 4 is 3 by 4, right? Calculating all these things, we will 1 by 3, we will, let's see how much we get it here. Let us calculate this. Here is this, so we'll need a box here like this. Okay, now in this box we will need to do the calculation. So it is 1 by 4 into sorry, 1 by 4 into 3 by 4. Yeah, 1 by 4 into 3 by 4 minus 1 by 4 into minus of 1 by 4 divided by 3 by 4. So how much do we get here? This is going to be 3 by 16 plus 1 by 16, sorry, yeah, 1 by 16 divided by 3 by 4. So it is 1 by 4 divided by 3 by 4. It is 1 by 3 is the answer. So here I'll get 1 by 3. Okay. The next element below it, minus 1 by 4. So for minus 1 by 4, how much I will have to do? I will have to do this here. Here like this. So 1, let us calculate that. Make a box and let's see. We will have here minus 1 by 4 into 3 by 4 minus 11 by 4 into minus 1 by 4, whole thing divided by 3 by 4. Let's do this calculation. On doing this calculation, you get minus 3 by 16 plus 11 by 16. So here it is 8 by 16, that is half. Yeah, divided by 3 by 4, right? So half divided by 3 by 4, so it is going to be 4 upon 3 into 2, so it is 2 by 3. So here you get 2 by 3. The next one, in the next column is 0, so let us do that. in mind you can make this box. So here oh, 0 0 0, so this is 0, no problem. Great, happy when you get all these like this zeros. So again when you have this 1, let us see, 3 by 4, here you get 1 again, so here you will get 1. What about 0s3? Yeah, so here it is like this when you calculate. So now we will get some value now. 0 into 3 by 4 is 0, minus 1 by 4 upon 3 by 4. So here it is minus 1 by 4 upon 3 by 4 is minus 1 by 3. That is what we get. The next one, with one element we have there. The next is 0. So here it is like this, 0 and minus 11 by 4 upon 3 by 4. So here it will be minus 11 by 3 you will get. So here it is minus 11 by 3. Okay. Okay, I have erased all those calculation, and now we go for the calculation for RHS. While calculation for RHS when we do, it will be how much it will be for 6 when we are calculating. Here it will be like this, a bracket we will again make a box, and so it will make a rectangular box in this manner. So it is 6 into 3 by 4 minus 3 into 4, oh sorry, 3 into 1 by 4, 3 into 1 by 4 divided by 3 by 4. So that calculation will give me 18 minus 3, so 15 by 4 divided by 3 by 4, so this is 5. So this value is 5 here. The next one, when we calculate over here, how do we get this answer? Let us see. 11 by 4 and this 15, right? So okay, so this is going to be, the calculation is slightly different here. Formula remains same, but then we have to change the numbers. The thing is going to be 11 by 4 into 3. Okay, 11 by 4, oh sorry, wait, not 11 by 4, the old element is 15. 15 by 15 into 3 by 4 minus 11 by 4 into 3 divided by 3 by 4. So here it is going to be 45 minus 33, that is going to be 12 by 4 divided by 3 by 4. So it is basically 4 is the answer there. Okay, so here we get 4. So all this answer we got. Now we have to calculate the last thing that we needed. The thing that we needed here was ZJ CJ. ZJ we will need Zj and Cj minus Zj. Cj minus Zj we have to calculate. So now while calculating Cj minus Zj, let us do that. So first we do Zj. Zj is obtained how, see here. Those of you don't understand how did we get Zj. Zj I'll calculate the first column. So it is basically 5 into 0 plus 0 into 0 plus 2 into 1. So basically the answer is 2 over here. The next one, again for the second column, here it is 5 into 1 plus 0 into 0 plus 2 into 0. So this is 5. Same way in the next one. So 5 into 1 by 3 plus 2 into 2 by 3 into 0, and then there is 2 into minus 1 by 3. So that is going to be 5 by 3 minus 2 by 3 is 3 by 3, so that is 1. So same way here it is 0 and here it is going to be 1. And finally this total here, how do we get 5 5s are 25? Okay, 5 into 5 plus 0 into 4 plus 2 into 4, so that is 8, 33. 8 plus 25, 33. Now let us see whether what do we get for Cj minus Zj. Cj in the starting column is value of Cj in the beginning is 2. So 2 minus 2 is 0. Second here it is 5. So 5 minus 5 is also 0. Then for S1 it is 0, so 0 minus 1 is minus 1. Second S2 it is 0, so 0 minus 0 is 0. S3 it is 0, so 0 minus 1 is minus 1. Here we get our answer. Now we stop. Why do we stop? Because we stop now. We stop here. Because Cj minus Zj values are all are are 0 or negative. So we stop here. Okay, we stop here, and so otherwise you will feel how much to continue this method. Okay, because it is elaborating and time consuming, so I always suggest that do it very carefully. 3 iterations also some people feel extremely tiring, and they feel it is you know great confusion, because if one value is wrong, all the things will go wrong. So I suggest you that whenever you are doing this method, do it with peace of mind. See to it that you have time enough to cross check your answer, and do it with extreme precision. Otherwise you can keep this method at the last. Okay, so now we stop here. So now we are going to conclude. So conclusion, what is the answer then? What do we got out of this, right? So here we conclude our answer that x1, how much is the value for x1, x2, x3, everything we will be able to say that. See, we got the maximum z max, we got. Conclusion is z max is 33. This is the value. This is the value that we calculated. Okay, this is z max. Okay, How much is x1 then? X1 is going to be x1 is going to be 4. X1 is 4. How do we get that x1 is 4? X1 is 4, we got it over here. See this. X2 is 5. Okay, x1 is 4, x2 is 5, and s2 is how much? S2 we got the value as 4. S2 is also 4. This is all that we have. And what about the other one? See, these are the basic variables that we got. Okay, these are basic variables, and the non-basic one that we take, non-basic are s1 equal to 0 and s3 equal to 0. These are the non-basic variable. Now we go through the entire method once again, a recap, because there were calculations and there were explanations over here. So I hope you followed these explanations. I know it could be a bit confusing at your end that how did this happen, but if you watch the video again, you will surely follow how the calculation started. Let me re-explain you. And see, I have not taken up the technical definitions which are there in the table. There are many technical definitions in the table at each step. For currently, for understanding how to solve, I am avoiding them. Okay, so first you understand how to handle the terms, later on you handle the calculation, later on you can dive into the definitions in detail. Okay, so these are the tables that you will need, and this is all about the simplex method. So I'll explain you again carefully. Firstly, step number 1. Step number 1 is calculate the standard form of your LPP. So you need to convert your given LPP into the standard form. So here it is maximization type. I have written down all the constraints here into the as a equality, and I have written down the non-negativity conditions also. After that, you are going to make the simplex table. I strongly suggest that take left hand side and right hand side. So when you are having your answer paper, like this kind of answer booklet is there, so take 2 pages side by side. Okay, side by side, and on the left hand side you start your question, write the LPP and standard form of LPP. It will take only half the page, but here you make the table, make simplex table here. Okay, and once you give your headings here, just put a long column like this, so all those will drop one below other. So not a big difficult thing. So you make the whole thing one below other only, don't keep making tables again and again. So here that is one thing. So this is one simplex table that you see. Now this is the main table from which you take your data. So your data that is there in the standard form of the LPP, you write down here. What all things are required? First row is CJ. CJ row is written once only in the table, you don't write again and again. Okay, it is a fixed row, it doesn't changes in the table. Cj row remains same. Okay, so it is, once you write, you keep it fixed. The next, cb row. Cb row, when you are cb is the column basically, so in below that you write down cb, the basic variable. Basic variable standard name is basis. Okay, x1 x2 s1 s2 s3 you write down the RHS and the ratio. First you write down till RHS, ratio you leave some space. Fill up the table carefully till S1, S2, S3. Whatever number of slack or surplus variables are there, you write down here. Corresponding in CB, you write down the coefficient of the slack variables. Fill up the table carefully and then calculate ZJ and CJ. ZJ, I have given you the formula. It is summation CB into AIJ. Okay, cb into aij, basically what you have to do, you have to do the dot product of cb vector with every column and write down the answer. Okay, do the dot product of every column and write down the answer with cb column. Okay, cb multiplied by every column you do, you will get your answer. So that will give you the value for zj. Okay, this is zj formula. Once you get zj, you do cj minus zj. So cj row you have already written, zj you just calculated, and do this. Now you have, you are in a position to find the key row and the key column. So first we find key column. Key column is found by taking the maximum element which is positive in the row of cj minus zj. Okay, I'll give here in writing. I'll write here with red. Key column is chosen as chosen for that for element which is maximum and positive, which is maximum and positive, that element will indicate the key column. Okay, now you divide the key column with the RHS, so that RHS is divided by the key column, you get ratio. Okay, ratio is obtained by RHS divided by key column. Key column. Now this RHS when divided by key column, you have to choose minimum to find the key row, minimum ratio to find the key row. Okay, I'll write here, choose minimum ratio to find key column. Okay, key, choose minimum ratio to find key row. Okay, now if any value is 0, or I'll give you everything in writing in the next video lecture, then you will get the whole idea. So if any value is 0 or negative, you discard that. Okay, ratio cannot if any ratio comes 0, negative, infinite, you discard them. It happens sometimes, and we will see some other cases also. So here it is like this. Having done that, you find key element. Okay, key element is the intersection of key row and key column. I'll write here, key element is the equals to intersection of key row and key column. Okay, now after that, once you find key row, key column, you are now in a position to tell which variable is entering, which variable is leaving. So the one in the row will leave and the one from the column will enter as a basic variable. Okay, so here in this case x2 entered and s1 left. Having done that, here now what is the next thing you have to do? Whichever key column you chose, okay, till the basic variable, you have to write everything as the uh, unit matrix, unit vector. Okay, divide that entire row, key row, by the key element, and then write the entire key column as a unit vector. Once you start writing, you have to use this formula to find new element equal to. The new element is given by this formula. You can use entirely this. You have to use this formula till the RHS is written. So for everything you start finding, you will get your answer. And then again you calculate all the values, and at CB column you give the coefficient whatever is there. Perform this process till the time you get all the values in the CJ minus ZJ column as 0 or negative. You have to keep on performing till the time you get all the CJ minus ZJ 0 or negative. 0 or negative, both are allowed. If anything is positive, you still need to work. So till that time you keep on doing. Once you get all that, you have you get the desired criteria, you have reached the final solution. The table number 3 is your final solution here. So this is the final solution. Once you obtain, you get your answer. So Z max is obtained from the ZJ row, and your final answer x1, x2, x3, whatever are the basic variable, here whatever you get in the basis, okay, this is basis 1, this column will give you your solution. Your answer is at the RHS, whatever is your RHS, that will be your value there. Okay, so I hope you have followed this process and the whole thing. Now I know it's a very lengthy lecture I must have taken, but I hope if you have been able to follow and have understood, please hit like and please share it with your friends. Do explain them how to help, how to calculate. And I know it is very nice gesture to explain your friend such a long method, obviously, but please do like the video, do share it with your friends, and uh, I would be very happy if you subscribe and press the bell icon and get the whole thing done. So now let me explain you how to handle the whole process here. So the first thing here you will need to do, I'll explain you in my language, in a very simple way, so that the whole process becomes evident to you. I'll explain you another algorithm in the next video, a much general one, because Right now what I have explained is for maximization. For minimization things are slightly different, a little bit a different way. Process is almost similar. Okay, so a difference is there, but then I don't want to create a big fuss with minimization right now because it's a first problem. Let it go smoothly. So step number 1, steps. Okay, step number 1, steps to solve simplex method. Now I am giving you for minimization, for maximization type. Okay, for maximization type. Minimization I'll handle in the next video. Maximization type. Given LPP to be converted to its standard form. To its standard form. Second, formulate, rather formulate nahi, form I would say, form the simplex table 1 as shown, as shown. So here you will have Cj. Okay, below that there will be basis. Here there will be CB. Here whatever x1, x2, x3 whatever will be there, then there will be s1, s2, s3. I am not saying that there won't be more variable. There can be x4, x5, x6 also. Okay, accordingly this is just a example for you people. Write down the RHS over here. Okay, write down those RHS, and here there will be s1, s2, s3. Okay, write down the coefficient, and remember here that this will be always an identity matrix. This is identity matrix here always. So here these are always zeros, and here whatever the coefficients are there, fill up them. Okay, fill up, fill, fill up the, fill up from constraint, from constraint. Okay, and this is fill from objective function. This is objective function coefficient. Now after that CB is all zeros. This is 0 0 0. Then you calculate Zj. Okay, Zj in the first place it is always 0, no problem, but sometimes there can be some values, so be very careful. And here these are the RHS, whatever RHS is there you fill up over here. Okay, now let's say this is basically this is B1, B2, B3, something will be there. Here actually it is constraints. When I say this is all A11, A12, A13, A21, A22, A23, A31, A32, A33, all these are there. Okay, basically this is here. So this is Zj. So Cj minus Zj to be calculated. Some values you will get here also. Okay. Now how do you choose your key column? Key column I'll give you. Key column is found by choosing the value which is maximum and positive. Okay, value which is maximum and positive. This is how you find key column. Then key row is found by key row is found by dividing RHS by key column. Key column. Yeah, key row na. Key row. Key element. Key element is found by the by no, key row is not only done by doing this, but then and by dividing RHS by key column. So the ratio, I'll rather say ratio, this is ratio but it is called replacement ratio. Replacement ratio is equals to RHS divided by key column, and this replacement ratio you have to take, and then it should be minimum. Okay, choose the minimum non-negative ratio. Hmm. That row becomes the key row. Okay, then the next one. So these are step number 1 is done, then this is step number 2. I can say this is step number 2 rather. Okay, step number 1, 2, oh, step number 3. Now next is this key row. So key row done, then we find key element. Key element is the intersection of key row and key column. Okay, we generally key row we generally mark key element as star or in box. Okay, something like this, box or circle. And key row we will always put an arrow, and for key column we always put a upward arrow and downward arrow at the end. Okay, so done. We are done with ZJCJ. We are done with finding key element. Now after finding key element, we then write, we then obtain the leaving variable and entering variable. Then this is step 4. Make new simplex table. Make new simplex table as shown above. As shown above. As shown above. I would rather say in above example. In above example, hmm, above example. So while making, what you have to remember, first thing, in new table, divide every divide key row uh, like yeah, in new table, divide the key row by key element. Key element. Second, in new table, the key column is made as a unit vector of the form of the form 100 or 010, something like that. Okay, I'm just putting in a general one, so you just see how does it work. 0, something like that. And then or something like 001 dot 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 0, something like this. Wherever the key row is there, key row, key column will be there. According to this, key column will be made of this type. Then third, then the remaining entries are found using the formula new element is equals to old element into key element minus corresponding element in key row into corresponding element in key column divided by key element. Okay, you do this. Okay, the key element, you do this, and then after finding this table, we do find, then find, then again find zj and cj minus zj, cj minus and cj minus zj. Hmm. Again cj minus zj. Okay, continue the step 2 3. Okay, continue this, continue the st step 2 and 3 till all cj minus zj, cj minus zj become 0 or negative, 0 or negative. Okay, that is cj minus zj should be less than 0. Hence we obtain our solution, our optimal solution rather, our optimal solution, our optimal solution. So this is the algorithm for the, you know, simplex method, and this is how it works. Now see, it may be, because this is the first example, it may be laborious for you people to, you know, work across all these examples and how it came and how did it work and how did it go about. So be careful while doing these questions. Don't be in a hurry to solve the questions in a fast mode. So be very careful while doing all these, because any one single mistake, it will create a big problem for you to handle, because immediately in the next question everything will become, in the next iteration, if you do one mistake, it will become all will go in vain, and solution will become infeasible. So don't do that, be very careful while doing it. Okay, and you need ratio over here, something like that. Okay, so here this is all how to be done. I hope you liked the lecture. Please consider liking the lecture and share it with your friends. Do it slowly, gently. Again see the problem, again do it in a fair work. All the extra steps which you feel you can avoid it, the I have written all the theory also along with it. In the next video lecture I will be avoiding all the theory and completely focusing upon the problem for solving. Okay, so I have given you your the example with the theory and all the detailed explanation, the minimal detailed explanation I have given you. So thank you for joining in this video lecture. Please hit like and share it with your friends. I'll see you soon with the next example in the next video lecture. Thank you.